Okay, so now that we learned a little about congruence, and mostly we worked with triangles, the rest of this unit we are going to be dealing with triangles. So we're going to talk about some congruence shortcuts, where before we needed to know that every pair of sides and every pair of angles was congruent. For these shortcuts, we're only going to need to know a pair of sides, a pair of angles, and another pair of sides to tell whether two triangles are congruent. So this first shortcut is called side angle side. And what it says is if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, the two triangles are congruent. So in this diagram, we have AB and DE, and then AC and DF. Well, A is the included angle between those two congruent sides. So knowing what an included angle is going to be the first thing we work on in example 1. So in example 1, identifying included angles. It says name the included angle between each pair of sides given. So with JK and KL, I'm going to highlight JK and KL, and I'm going to circle the included angle. That angle is angle J. All right, and it's okay that we name it angle J because there aren't any other sides coming off of angle J that are confusing. So that one we can just name angle J, that is fine. The next pair of sides, LP and LK. That will be this side, LP and LK. So for this angle, I can't just name it angle L. I'm going to have to name it using 3 letters. So I'm going to say it's either angle KLP or angle PLK. Either one works, but we have to use 3 points to name that angle, else there's some confusion. So that's why I named that with L in the middle. But an included angle is the angle formed by the two sides that are intersecting. And then the final one here, KL and JL. So KL is here, JL is here. So again, they meet at L, but the way I name this is important. So I would say angle JLK or angle KLJ. Either one will work. All right, but it's naming it specifically, not just angle L, because there's a lot of different angle L's in that corner of that shape. So that's the important part. Next, deciding whether there is enough information given to prove that the triangles are congruent using just this SAS. And we are going to get some practice doing it. So I'm going to do a few, and I'm going to try and have you do a few. So in this first diagram, ABD and CDB. So the thing here is, we already have a pair of angles and a pair of sides marked as congruent. There is a pair of sides we can say are congruent. We can say that BD is congruent to DB because we call that a shared side. Now when we look at this, yes, we do have 2 pairs of congruent sides and we have 1 pair of congruent angles. But is this congruent angle included between the congruent sides? It is not. So we would say no. The angle isn't included. The congruent angle isn't in between the congruent sides, so we can't say those are congruent. As for part B, we look at this set of triangles potentially being congruent. Both of these angles are right. They're both 90 degrees, meaning they are congruent. So this pair of triangles is congruent by SAS because we have 2 pairs of sides and the congruent angle, and the included angle, the included angle are congruent. So that included angle is important. So it's always two sides, two pairs of sides, one pair of angles, and they have to be included. That angle has to be included. Okay. So might be a good idea for you to write now. Try and do C and D on your own. Pause the video, work through them, and then once you're ready, resume the video and I'll show you what I got as an answer. Okay. Okay, so for C and D, both of them are no's. And with C, we can assume that ZX or XZ is congruent to XZ because those triangles share that side. And we can assume that, WXZ, this angle on the left, is a right angle. Now, yes, we have two pairs of congruent sides and one pair of congruent angles. On the left-hand side, yes, that's an included angle. On the right-hand side, that right angle is not included between the two sides. That is why those are not congruent by SAS. In part D, they are not congruent, and neither of these angles are included. So, yes, we have two congruent sides, one pair of congruent angles, but that is not an included angle. So we can't say they're congruent by SAS. For part E, these two triangles, we've got to think a little bit. They do share a side. I'm going to show that. Now, when I look at it, we have included angle. So I would say, yes, those are congruent by SAS. And I would say it's because two pairs of congruent sides and, write a better A there, and the included angle. Okay, so yes, two pairs of sides and the included angle are congruent, right? And then the final one, 14. If we look at this KLM, MNK, two things here. First, that shared side. And then with this, you got to look at the parallel lines, okay? If we look at these parallel lines, we have to look closely, but this angle right here and this angle right here, NKM, is congruent to KML. And if we remember back, that's alternate interior angles. Those are alternate interior angles. Now, if we look at it, we do have the pairs of sides, we have the pair of angles, but these are not congruent by SAS because angles aren't included. They're not between the sides. So the next step in the lesson is to get a little practice with just identifying included sides and doing the SAS stuff. You're going to come back to these second half of the notes later in the lesson, but right now you're just going to get a little bit of practice with SAS.